So guys, as we have seen the extraction of the metals using a method of your pyrometallurgy, soon after the pyrometallurgy we have also seen the extraction of aluminium from purified alumina through your electrometallurgy. So these were the two important, or we can say different kinds. So in pyrometallurgy we used a specific temperature and a specific reducing agent. Whereas in the case of your electrometallurgy, we have chosen a particular electrodes and their respective electrode potential. The another method what we are going to see is called as that of your oxidation reduction method. Oxidation and reduction method. Yes. So basically, this is a process where we are going to see the extraction of gold and silver. Of course, we have dealt with it when we were having the classes. Yes, the leaching process. Just you have to keep a concept of the leaching process over there. The same reaction we are going to study over here, but under the heading, because it is involving the extraction, called as oxidation and reduction method. So if you are remembering, in leaching process what we have done is, of course, whatever the ores of your gold and silver we were obtained, they were first treated with a dilute solution. Please mark my words, dilute solution of your sodium or a potassium cyanide in the presence of oxygen. Yes, the same thing you are going to see, and we are going to see that why this reaction is called as oxidation and reduction method. So basically what is happening, first the gold ore, of course it's an ore I have taken, okay, of course it is having some impurity. First it is treated with that of your dilute solution. Solution means of course you will be also having water, dilute solution of your potassium or sodium cyanide. Just I am writing the ionic equation in the presence of oxygen. So what you are going to get, an or cyanide complex AuCN twice minus alva, plus in order to overall balance you will be getting as that of your OH minus. In order to balance this, you will be having 4 times of your gold, 8 times of your Cn minus, yes, 2 times of your water. So just you have to remember this reaction by the way you are using. First you are taking the ore, then you are adding that of your cyanide solution in the presence of oxygen. 4 2s are 8. So by this way, if you are remembering any one of this, of course you will be getting the other part. So what you will be getting over here, since we are having the gold part 4, yes, 4 you will be getting. See, if in case if you are not remembering this 8, if you are just remembering the 4, so when you are putting in the complex, what happens? 4 2s are 8, so 8 cyanide you should get. So of course now how many hydrogens are there? 2 2s are 4 hydrogens, and that of your 4 oxygens. So here we will be getting as 4 OH minus. So what is happening over here? Of course in the redox we have seen, whenever we are taking any metals in their whatever their normal state, elemental state, it will be having an oxidation state of 0. So in the complex what you are getting, if I take my gold as X, yes, plus each cyanide is an anionic ligand which is having a negative sign. Remember, cyanide is an ambidentate ligand. Just for your knowledge purpose, we are just revising it. In the complexes we have read it. So cyanide is here what? Anionic ligand. So each cyanide ion is having -1 charge. Like that, how many are there? 2. So 2 into -1. So overall complex is having a charge of -1. So overall is equals to -1. So X will be equals to -1, yes, plus 2. So X is equals to plus 1. So from gold, from the 0th oxidation state, it has been changed to plus 1 oxidation state. So what is happening over here? Gold is undergoing an oxidation by forming a cyanide complex. But it doesn't stop over here. Instead of what I have to do, I have to extract this gold from the complex. So how I am going to do it? Of course, by taking that gold complex AuCN twice minus, yes, in the presence of zinc I am going to use it. While I am choosing the zinc, you can refer to that of your electrochemical series. You will be getting an option. So zinc is a better reducing agent over here. So what it will do now, it will go inside this complex and in turn the gold will be kicked off. So what you'll be going to get over here, 2 times of your AU. If I put here 2 times of your AuCN twice plus Zn CN4 2 minus alva. So of course we have seen here we were having the +1 state. Once again now it has been reduced to 0. That means what? There is a gain of electrons. That is, a reduction has taken place with respect to the gold. That is the reason why we are calling it as an oxidation and reduction method. So in an oxidation reduction method, mainly we are using that of your silver and the gold ores, where we are treating with a dilute solution, mark my words, dilute solution of that of your cyanide, potassium or the sodium cyanide in the presence of oxygen. So where you are getting as a gold complex, cyanide's gold complex, yes, where the gold has undergone an oxidation. So in order to extract this gold from its cyanide complex, we will be using your zinc. Of course, why we have chosen the zinc, it is referred with respect to that of your electrochemical series. Yes, so what will be happening, zinc will be having the higher affinity than that of your gold. So it will be going inside that of your complex, instead kicking out of that of your gold. So from +1, once again it changes to that of your 0, undergoing your reduction. That is the reason we are saying it as an oxidation and reduction method. Is that clear? So let's have a quick review of whatever we have done. So in pyrometallurgy, what we have to see, of course we are using the ores that has been roasted or calcined, and they are treated at a specific temperature using a specific reducing agent. How you are going to use that reducing agent? It is through your Ellingham diagram. So in the Ellingham diagram, one important thing you have to remember, that if this is the curve of your delta G versus your temperature, and you are having the two curves is in this way, if I think, yes. So let us say this as some temperature, some as T1 I would be noting. Let this be some metal, okay, which has been reacting with that of your oxygen to give you as a metal oxide complex. Let this be as that of your another, say, coke itself, which is giving you as. So when we can use the coke as a reducing agent, just one important thing you have to remember, that whatever the reducing agent you are going to choose, yes, that should lie below the curve of your ore oxides. Able to understand? Don't get confused. ಏನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಇಲ್ಲಿ ಅಂತ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ ನೀವು. ಈಗ ನೀವು ಎಲ್ಲಾದ್ರೂ ನಿಮ್ಮ ಕೋಕ್ ನ ರಿಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ ಆಗಿ ಯೂಸ್ ಮಾಡಬೇಕು. ಅವಾಗ ಏನ್ ನೋಡ್ಬೇಕು ನಾವು, ಆ ಕರ್ವ್ ಅಲ್ಲಿ, ನಿಮ್ಮ ಕರ್ವ್ ಅಲ್ಲಿ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ ಏನಾಗಿರ್ಬೇಕು ಅಂದ್ರೆ, ಆ ಕರ್ವ್ ನಿಮ್ಮ ಮೆಟಲ್ ಆಕ್ಸೈಡಿನ ಕರ್ವಿನ ಕೆಳಗ ಭಾಗದಲ್ಲಿ ಇರಬೇಕು. ಅದು ಯಾವಾಗ ಸಾಧ್ಯ? ಆಫ್ಟರ್ ಸರ್ಟನ್ ಟೆಂಪರೇಚರ್ ಪಾಯಿಂಟ್. ಇಲ್ಲಿ ನೋಡ್ಬೋದು ನೀವು, T1 ಕಿಂತ ಹಿಂದೇನಾಗಿದೆ, C is at the top and M is at the bottom. ಹಾಗಾದ್ರೆ ಏನಾಗ್ಬೋದು, ಅವಾಗ ನಂಗೆ ಈಗ ಎಲ್ಲಾದ್ರೂ CO ಕೊಟ್ಟು ರೆಡ್ಯೂಸ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಅಫ್ಕೋರ್ಸ್ ಐ ಕ್ಯಾನ್ ಡೂ ಇಟ್. ವೆನ್ ಬಿಲೋ ದಿಸ್ T1 this metal can act as a reducing agent because it is lying below. ಯಾವ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ ನ ಯೂಸ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಆ ಕರ್ವ್ ಕೆಳಗ ಭಾಗದಲ್ಲಿ ಇರಬೇಕು. T1 ಕಿಂತ ಜಾಸ್ತಿ ಹೋಗ್ತಾ ಉಂಟು ಅಂದ್ರೆ ಅರ್ಥ ಏನು, ಈಗೇನಾಯ್ತು, ನಿಮ್ಮ ಕಾರ್ಬನಿನ ಕರ್ವ್ ಕೆಳಗೆ ಬಂದಿದೆ. ಸೊ ಅವಾಗ ಅರ್ಥ ಏನು, ಇದ್ರ ಮೇಲ್ಭಾಗದಲ್ಲಿ ಯಾವೇ ಒಂದು ಮೆಟಲ್ ಆಕ್ಸೈಡ್ ಇದ್ರು ಅದನ್ನ ನಾನು ಈಸಿಯಾಗಿ ಮೆಟಲ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡಬಹುದು. ಸೊ ದಿಸ್ ಇಸ್ ವಾಟ್ ದಿ Ellingham diagram is stating. Is that clear, guys? So in pyrometallurgy, this is the main concept. So in pyrometallurgy, we have seen the extraction of your iron from that of your iron oxide using the coke as a reducing agent in that of your blast furnace. very much important. The two important reactions we have, conditions we have seen, that is a reaction which is taking place nearly at 500 to 800 Kelvin, and the reaction which is taking place at 800 to 1500 Kelvin. Very much important. They can ask you any of the things in these reactions. Okay, then we saw the extraction of the copper from copper pyrites. Of course, we are writing it as a copper sulfide, but do remember that copper pyrites is having CuFeS2. On roasting this part itself, we have got Cu2S plus FeS. So afterwards, whatever we are getting, of course, which will be a composition of your copper matte. Yes, copper matte. Here also, once again, I have to just make you one thing aware. As the percentage of the carbon decreases, quality of your metal goes on, or quality of your iron, I can be more specific, quality of your iron increases. So very least quality is your pig iron, afterwards is your cast iron, and afterwards is your wrought iron. Okay, similarly in the case of the copper also, the copper matte, whatever we have obtained from the top of your this one, what you can say, reverberatory furnace, is your copper matte. Once again you are going to treat it. Yes, so after that one itself, you are going to get that of your pure copper. Okay. Then in the pyrometallurgy, we have also seen the extraction of zinc from zinc oxide. Once again, using your coke as a reducing agent. Here also we have used the coke as a reducing agent. Nothing more you have to think of it. In all the extractions in pyrometallurgy, we have chosen coke as a reducing agent. But the one important change what we have done is the temperature condition. From iron oxide to iron, we have maintained a temperature of 1473 Kelvin. Why this one? Because above this temperature itself, your carbon to carbon monoxide curve is lying below that of your iron to iron oxide curve. Is that clear? And the next important thing is, in the extraction of iron from iron oxide, we have chosen limestone as a flux. Limestone as a flux. Coming with respect to copper sulfide, you could just see that we have maintained a temperature of nearly 500 to 600 Kelvin. Why is that so? Because at this temperature range, what is happening, our carbon to carbon monoxide curve is lying below that of your copper to copper oxide curve. Able to understand? And of course, what is the flux you have used over here is your silicate. And what the slag we are getting over here is your iron silicate. And whatever the slag we have got over here in that of your extraction of iron, yes, calcium silicate. You have to please do remember this part. It's very much important. In zinc to zinc oxide, nothing much here. We are not saying anything, but we are saying a temperature range which is of course greater than that of your copper. And here what we have done is we have obtained the zinc through that of your distillation process. Yes, and the extraction, once it has been done, the amount of the metal we are getting solidified by rapid chilling. So this is the part of your pyrometallurgy. Coming with respect to that of your electrometallurgy, what we can say. So basically in electrometallurgy, we have to remember that it is through your electrolysis process using your equation of delta G is equals to minus of NF into E naught. So depending upon this E naught, if the positive value of the E naught is existing for the two reaction, that is the oxidation and reduction, delta G will be negative. So the reaction will be taking place on its own. Yes. So in the extraction of aluminium from purified alumina, we have seen that we have used a cathode, what? A steel vessel which has been lined with your carbon. Yes, lined with carbon. And the anode we have used as that of your graphite rods. Yes. So whatever along with this one, we have taken an electrolytic solution as what? Your molten alumina. Yes, your molten alumina. Plus what you have chosen? Cryolite, which is having a composition as what? Na3Al(F6). Why it has been used? Because it is acting as electrolyte. Along with this one, we have also used my fluorospar. Yes, calcium fluoride, fluorospar. Don't remember as a calcium fluoride. Remember the name as fluorospar. So here what it will be doing, it will be lowering the melting point and also increasing the conductivity. That is the reason we have used it. So once the reaction is taking place, very much important, at cathode what is happening? Of course, Al3 plus 3 electrons it has been gained to give you air. At anode, what is happening? Whatever the carbon rods were there, that is your graphite. Remember, both your cathode and anode, both is containing carbon itself. You have to remember this point because very much important in your competitive exam. So at anode, what is happening? C plus O2 minus, first it gives us CO, then C plus 2 O2 minus give rise to that of your CO2. So again and again in this reaction, we are going to replace our anode. Why? Because whatever the carbon monoxide and carbon oxide has been formed, that is going to consume your carbon. So for every 1 kg of aluminium obtained, nearly 0.5 kg of your graphite rods are used. Okay. So that is the reason in this reaction, in this process, which is called as Hall-Héroult process. In this Hall-Héroult process, we are going to again and again change this anode. Change and we are going to replace that of your graphite rods. So this is the main thing. Overall reaction and remember guys, in exam they can ask you specifically give the cathode and anode reaction and you have to write it in this way. In case if they have given you to write that of your overall reaction, means you have to write the overall reaction as Al plus that of your 3CO. Yes, this is the overall reaction. So don't get confused. Overall reaction anta heli idun bardre they will not give you the marks. Overall reaction yenagta untu particular agi ಆ vessel ಅಲ್ಲಿ ಏನಂತ ಬೇಕು. Since it is an electrometallurgy, cathode ಮತ್ತೆ anode ಅಲ್ಲಿ ಏನಾಗ್ತಾ ಉಂಟು ಅಂತ ನಮಗೆ ಗೊತ್ತಿರಬೇಕು. Either of the things they can ask you. Okay, so this was the concept of your electrometallurgy. Coming with respect to that of your oxidation reduction, as we have explained, it is mainly used for that of your leaching process of your gold and that of your silver, where we are using the dilute solution of your cyanide in the presence of oxygen, where your gold is first getting oxidized, then by utilizing the zinc as a reducing agent, yes, which is going to replace your gold from that of your cyanide complex to give you that of your gold in its elemental state, which will be having a from +1 to 0 reduction takes place. Hence the name is called as oxidation reduction method. So one important thing we have to remember over here. So as soon as one first is your mining process. So from the mining process, whatever the ore we have been got, first it is subjected to concentration. That is through your froth flotation, gravity separation, magnetic separation, all those things, leaching process. So once the ore has been removed with that of your sand and stone particles, after the concentration of ore, we are going to burn those ore, and it is undergone with respect to that of your calcination. That is, in the absence of oxygen, some ores will be burnt, and also roasting. That is, some ores which will be burnt in the presence of oxygen. Soon after the burning of the ores, the next important thing we saw, the extraction of the metal. Extraction of metal, yes, using your reducing agents, more particularly, yes. So in this extraction of the metal, of course, we have removed nearly 90% of the impurities. But also on 10% there will be existing. So the final process which we are going to see in our next video, which is called as the ultimate final process for the extraction of the metal, which is having the different categories under this heading, called as refining. So once whatever the metal we have extracted from this extraction of the metal, it is further subjected to a process which is called as refining. So of course, depending of the properties. So in this refining, mainly we are going to select a particular method for a particular metal using the difference in the properties, yes, depending upon the properties of the metal and that of the properties of impurities. So in our next video, the last part, we are going to see the important concept, that is the extraction of the metal in its purest form through that of your refining, which is based on the property of your metal and that of the property of your impurities. So once again, I'm just going to remind you, make sure that you have been known with an idea of Ellingham diagram, because much of the concepts in your competitive exam will going to arise in that concept itself. What is the main thing the Elingham diagram want to say? Just make yourself clarified with it. Okay, so in our next video we'll be seeing the process called as refining.